Problem 12. A composite vertical plane surface shown is in contact with water. Determine the force acting on the gate and compute the moment of this force about axis AB and about axis BC. So, because this is a composite area, we will divide the area into two rectangles in that manner. So this rectangle is, the top is flush with the liquid surface, so we can easily locate the center of pressure, which is 2/3 of 3, so 2 meters. There's no need to solve for E by experience. Only this part where we have to solve for E. So therefore, if this is 3 meters, 3 minus 1.8, so that's 1.2. If this is 1.5, so 3 minus 1.5, this is also 1.5. And centroid of area 1, center of pressure of area 1, which is 2 meters from the top. 2/3 of 3 is 2 meters, then 1 meter from the bottom. For the second area, we have to solve for EV2. So this is where the force F1 acts. This is where the force F2 acts. Then the center pressure for the entire area would be closer to CP1 because the force F1 is greater than F2. So that's the location of the single force. We can actually locate the CP for the entire composite area if we want to, but we just want to solve it in a easy way by considering the components instead of the single force. It will extend our solution if we locate that point. We just use Varignon's theorem instead. So this is also 1.5. Then that's 2 meters. There's no need to solve for E. If you want to solve for E, solve it. Then plus 1.5, which is barred H, then you will get 2 meters. So let's just solve EV2 because the top edge is not flush with the water surface. So F is gamma barred H area, gamma of water barred H area. So for F1, it is 9.81. Barred H of F1, this is 1/2 of 3, so 1.5. Then the area is 1.8 times 3. So 9.81, 1.5, 1.8 times 3. So F1 is 79.46 kilonewtons. F2 is 9.81. Barred H2 is from water surface 1.5 because this is also 1.5 and this is a rectangle. 1.5 over 2. 1.5 plus 1.5 over 2, that's the barred H. Then the area is 1.2 times 1.5. So F2 is 9.81 times 1.5 plus 1.5 over 2 or 2.25. Area 1.2 times 1.5. So F2 is equal to 39.73 kilonewtons. Therefore, the single F here is simply F1 plus F2, 79.46 plus 39.73. So F is equal to 119.2 kilonewtons to 4 significant figures. Then, moment about AB. So moment about AB is F1 times 1.8 over 2 or 0.9. A moment arm of, because the force is acting here, so this is a rectangle, so this is 1.8 over 2 or 0.9. Plus F2, the moment arm is about axis AB is 1.8 plus half of 1.2. So plus 39.73 times quantity 1.8 plus 1.2 over 2. How you can follow. So moment about AB is equal to 166.9 kilonewton meter. While moment about axis BC, F1 times 1 meter because that's 2 meters plus F2 times this distance. This distance is equal to 3 meters minus barred H2, which is this one, 2.25, minus EV2. We don't have EV sub 2 yet, but we can derive that. EV is BH cubed over 12 for rectangle over area of rectangle BHR, barred H. That's the formula. I sub CG over area bar H. Then we will just develop a formula for E sub V, vertical distance for surfaces that are vertical, in for rectangular section, so that there's no need to proceed to I sub CG over area bar H. Just remember, it is height of rectangle square over 12 bar H. That's the formula if you simplify that. So since bar H is known, height of rectangle is 1.5. So it is 1.5 square over 12 bar H. Bar H is this one, 1.5 plus 1.5 over 2, or 2.25. So EV2 is 1 over 12 meters. 1 over 12 meters. So therefore, moment about axis BC is F1 times 1, 79.46 times 1 plus 39.73 times quantity 3 minus 2.25 minus 1 over 12 EV2. So again, this distance is 3 minus bar H2, which is 2.25, minus EV2. So moment about BC is equal to 105.9 kilonewton meter.